potential. If it goes further down and you get more and more cover, your corrosion potential will start low. Okay, so it clearly is a resistivity bound equation. So measuring resistivity is very critical in deciding whether you should make sense of that half cell or you should just say that's not a sensible half cell. Along with that, so half cell mapping is a good thing. I'll show you an example anyway. It's a theoretical example, and that's why I said we don't have a solution yet. But maybe you can develop that. So if you have a mapping of half cell mapping of an area, imagine there's a way you can overlap that mapping with something else. So half cell mapping, in my view, should be interpreted with the cover meter mapping. Okay? And that should also be interpreted with resistivity mapping. Because resistivity gives you an idea of the diffusivity. Cover tells you how far is that diffusivity relating to, and half cell gives an idea of the state of affairs of steel. For simple decision making, my suggestion will be to map 3 of them. If you know the old tracer paper method, if there's a way you can put a tracer paper figures and you put one on top of each other and have a look at it, you probably will take a decision on areas of concern for you. Basically, if the cover value is high, but your corrosion potential or your half cell is high as well, and your resistivity is average, that is an area for concern. Because if the cover was low, the potential will go up naturally. But areas where the cover is normal and the potential is high means there's something else happening there. There's no equation, unfortunately. I would love to, but I still haven't got that physics yet. Yeah.
First we go for a GPS and we go get the cover there.
Yep.
The reinforcements. Then we take all the nodes and we connect the half cell for the device.
Yep.
The reinforcement. And we take readings. So the equipment that we have, it gives all the 3 readings at one shot.
Yep.
So that we have to put the entries there, certain like grades, and we have to put the cover there, and all these things. We get the 3 readings.
Yep.
And we get a contour map.
Yep.
So the contour plotting we get.
Of the 3 different things.
Yeah, but on a different, like resistivity in a different graph, so potential in different.
Yeah.
But we are not able to get it in a combined, like how to interpret all the 3 readings at one shot.
Yeah. I presume you have a ProSec instrument.
No, we don't have ProSec, we are not using ProSec. We are using a Canadian based equipment called Gigatech.
Okay,
so
fair enough. ProSec, as far as I know, is working on a software which can, they have some sort of rolly, like a wheel-based system. So they're picking up the resistivity, and they're also trying to figure out a way of picking up the cover meter and the half cell. And they are working, whether they have been successful, I have no idea. They were working at interpreting the 3 to give you a decision. It's very tricky because it's a lot of physics involved in it, in taking that decision. Okay. Okay. That's where we are at the moment. I haven't really paid much attention to the corrosion side of things because you do need people like John Broomfield, who's really a corrosion expert, to explain things in a different way. Mathematically, not yet, but maybe you can try. Join up with somebody who knows corrosion and then pass the data and then ask them mathematically, can you make sense? It's not too far difficult to get an empirical relationship because I don't know whether you're familiar with things in the environmental science. They use something called principal component analysis. They can see how one factor is related to the other factors. We use that in the share market all the time. So that means you can get a relationship between these values, abstract values, and then you can build a picture afterwards to see how are they related. So it might be, if you have data, that might be a possibility. Scatter is the problem, but that's one way from experimentally going back to it. Fundamentally is what I would prefer to go, but I don't have the physics to do it yet. I was just waiting for somebody else to define the physics, but they're not sure yet anyway. So. Sorry, come on. Happy enough? Any questions? Okay, good.